Okay, the second way that we can combine functions or combine the Taylor series of functions to get the Taylor series for a more complicated function is using substitution. So we have this e to the negative x squared function. This is our f of x. And we want to know what is the Taylor series for this function. Well, we might remember that, hey, the Taylor series for e to the x is really easy. That's probably the easiest one out there. It's 1 plus x squared over 2 plus x cubed over 3. Because all of the derivatives are 1, it's straightforward to find. So to do the substitution, we want to reformat this, or we want to substitute something in to our e to the x function. So I'm actually going to use, I'm going to use the letter z. You could really use any letter, y, u, v, or, those are commonly used substitution letters, but, yeah, choose your favorite letter. The reason I'm using z rather than x is that we already have an x. The reason I'm using z rather than u is, well, we've done u substitution before, and I don't want to quite conflate them too much. But a u is probably the most commonly used substitution letter in this case. Anyway, I'm saying that z equals x squared, z equals negative x squared. And I'm going to go ahead and write down the fact that e to the z, or the Taylor expansion for that, as we've seen before, this is 1 plus z squared over 2. I'm going to put the 2 factorial there. 2 factorial is 2, so that's the same thing. Z cubed over 3 factorial, etc. Okay, and just like with the addition and multiplication, this is a really easy thing to do. Once we've set things up, once we set it up the right way, that's the tricky part, we can find e to the negative x squared. We can find the Taylor expansion for e to the negative x squared by following this rule, by replacing z's with negative x squareds. So 1 plus negative x squared plus negative x squared over 2 factorial, etc. All right, and I just want to point out that if a little bit of this simplifies, so 1 minus x squared plus x to the 4th over 2 factorial minus x cubed over 3 factorial, etc. Sorry, not cubed. X to the 6th over 3 factorial. So you might notice a structure of this, the fact that this is alternating and only the even factors. This looks a little bit like cosine, but because the denominators are actually fairly different, this ends up being a drastically different function. Just one thing I wanted to point out there. Cool, yeah, so that's just about it. The other thing I wanted to point out was this particular function, e to the negative x squared, is one of those functions that we had previously talked about not having an elementary integral. If we wanted to find the integral of e to the negative x squared dx, this thing doesn't have an easy answer. Like, it isn't that it's too complicated, it's just that there's no way of writing down what this function is other than by defining it to be the Taylor series we would get when we do this. All right, so in the next video, we're talking about differentiation and integration and how this ties into this. But I just wanted to point out that like sine of x over x, which is the example you should work on in your groups, e to the negative x squared is another one of those functions that doesn't have an elementary antiderivative.